Good morning, everybody. My name is Norman Baker, and I'm here hosting this meeting with you. And I come from the Campaign for Better Transport, which is an organisation, a pressure group designed to achieve sustainable transport, to encourage use of bus and rail, cycling and walking, and to help move the country and hopefully the world towards a zero emission future for transport. I'm also a former minister at the Department for Transport, where I covered rail and bus, that between 2010 and 2013. We've got an excellent panel here today, as you can see. They'll be delivering presentations on a range of topics around achieving zero carbon railways, such as exploring how to reduce carbon emissions through rolling stock, energy optimization, and alternative power sources, looking at how construction projects can be delivered more sustainably and with reduced impact on the environment, the environmental benefits of rail freight versus air and road cargo, and creating a modal shift to meet the industry environment goals. If we can do all that, it'll be a fantastic achievement. So let me introduce first of all the first of our panelists. Each is going to speak for 15 minutes or thereabouts. We'll then have at the end of that half an hour or so for questions and answers, which I'll be getting questions fed to me, so please do submit your questions. And I would just say that I would ask speakers to keep to time. We always like the railways to be on time, do we not? So please keep to your 15 minutes. I'm going to begin now with Andrew Cluth, who is a lead carbon specialist for the RSSB. You can explain perhaps, Andrew, what the RSSB does in your introduction. But part of the reason Andrew is here, I think, he's been contracted to draft a strategy in response to a ministerial call to remove all diesel only from the rail network by 2040 and to help decarbonise the rail network. So Andrew, over to you.
Thank you. For those who don't know about RSSB is an organisation that's been set up to support the railway in developing standards and guidance on various aspects of health, safety, and more recently sustainability. And about 18 months ago, Joe Johnson, who was then Rail Minister, asked the industry to consider plans to take all diesel-only rail trains off the track by 2040 and to come along with a vision as to how to decarbonise. And RSSB was asked to support a task force that was set up to provide an independent report from the rail industry to the Rail Minister to explain how to do this. More recently, in June of 2019, the original target of 80% carbon reduction by 2050 was amended to meet the national net zero greenhouse gas emissions target. So everything I talk about from now will be based in that context. But essentially what happened was that the task force, which was chaired by Malcolm Brown, who was then and is now again the CEO of Angel Trains, the task force had representation from major groups within the industry, Network Rail, Rail Delivery Group, Railway Industry Association, and others. And it produced two reports for the Minister, an interim one in January of 2019 and the final one in July 2019. And alongside that, there was work being undertaken by RSSB to support research and development in various aspects of how the railway might decarbonise. RSSB works in T numbers, and on the left-hand side of this, you see T1145, which was options for traction energy decarbonisation in rail. This was exploring the options for emergent technologies to support low or zero emissions traction in the railway. It found very early on that freight presented its own problems, and there was a further report on freight, which I'll talk about a little bit later on. But in essence, what happened was that the research established that there were two technologies that would be sufficiently mature in developmental terms within the timeframes required to make some sort of contribution to net zero rail traction operation. And this was matched against the three key categories of trains set out in the long-term rolling stock strategy. So these were trains which were running typically up to about 75 miles an hour, up to 100 and up to 125 miles an hour. And you can see from this chart that really, if you're trying to run a low carbon railway, electrification is going to be the only universal solution. The challenge we have with that is it's expensive to install and expensive to maintain. And to make a best use of it, you have to do it on an intensively used railway. Where you don't have that intensive use, there may be other traction options such as hydrogen and battery, which would be suitable for certain circumstances. Hydrogen tends to be good where you're trying to run for longer distance at slightly higher speeds. Battery for short run, frequent stop types of journeys, or where you need to bridge gaps, or where you need to be able to accelerate the train quickly, and there's access to regen braking. The subsequent work we've done tends to support the findings from that initial report, T1145 report on freight, but there are findings that suggest that hydrogen and battery could both make some sort of contribution to running freight in principle against model journeys. Again, I'll say a little bit more about that later on as to what the restrictions are. But essentially, the reports have concluded that there are possibilities for running hydrogen and battery services on the mainline rail network. The other thing we need to be able to consider is what happens when you're dealing with last mile capability, either where you're running into areas where you can't produce emissions, such as possible emergent clean air zones, or when you're coming off the mainline rail network and you need to be able to run services in freight terminals and other areas where there won't be access to electrification, even if there is a decision to electrify fully. The basic approach that was adopted by the task force, which has been generally agreed, is that where you have access to electrified network, either in current form or through infill electrification, to always make sure you run electric trains. Sounds really blindingly obvious. In practice, it's a bit more complicated than that. There have been operational reasons, technical reasons, and governance reasons which have predicated against running electrified trains all the time on the electrified network. One of the challenges is to make sure those get resolved. And the second time, looking at areas where there is no prospect of electrification within the timeframes, to make sure that we give clarity at the earliest possible stage on what the alternative traction options are going to be, and making sure that we start to deliver those as soon as possible to give us the longest lead time between now and 2050. The reason why I say that is because decisions need to be made over the next 12 to 24 months, probably, where the final decision that is made will either be in operation in 2050, or there will be a need to make some sort of conversion or traction energy engine exchange between now and 2050 if we're to deliver these sorts of targets. So we do know that there needs to be real clarity now in order to be able to deliver that 2050 target. That means then that with this grey area in the middle where the solution is not yet certain, that we should be working with the rail industry, with the DfT and with others, manufacturers, to squeeze that grey area in time and space as quickly as possible to remove uncertainty as quickly as we can. That is, I think, part of the ongoing debate we have. The task force was remitted to look in three key areas. So although we'll talk a lot about traction, we do talk a lot about traction. It was also asked to look at infrastructure and property. During the course of its work, it became apparent that we couldn't talk about this without having some sort of understanding of the governance and delivery aspects. So the task force then brought that into its consideration as well. Focus areas were reflecting the outcomes of the research, that we need to be able to look at passengers and freight both individually and collectively, that we need to look at the types of infrastructure we needed to support battery and hydrogen trains, that there will be certain types of difficult issues which need to be considered, even though they're very small emissions, such as yellow plant and line side energy sources. That property we need to be looking at stations and depots and the challenges they present. They're essentially very large buildings, but we have lots of precedents outside the rail industry as to what we can do in those areas. And then on the government and delivery side, making sure that the industry stays joined up, that if one part of the industry decides to move on its own, and there could be adverse consequences elsewhere if we haven't sort of thought about the way that things might interrelate. But being clear about policy and targets, and then making sure that we're delivering what we say we will. And the key areas I've mentioned already, we need to have those long-term targets in place, know how we're going to get there, but not make decisions at the last moment, to make sure that the transitional arrangements, where we're looking at interim targets, where we're looking at pathways for improvement, where we're looking at step change opportunities, as well as incremental changes, are all being considered in the way we're doing things, and that they have to be put in the context not just of the rail industry, but also in terms of national carbon budgets and other decisions being made outside the rail industry, which could have a bearing and influence on what we're doing within the rail industry itself. So I said RSSB work within the rail industry to provide support in research and development of various ideas. The task force made a number of recommendations, and RSSB put in place a very unimaginatively entitled decarb programme to explore various technical issues around the delivery of these new traction options. I've mentioned 1145 and 1160 on the left-hand side for passenger and freight rail. What we've also been doing is exploring the way that you might bring hydrogen battery trains into service, both in terms of safety to make sure that they meet the very stringent safety requirements on the railway, but also in terms of standardisation to make sure that if we develop a hydrogen or battery train to work in one part of the country, that it's going to be suitable to run on a go-anywhere basis somewhere else with infrastructure that might be installed elsewhere. Towards the right of this, we have a couple of other projects, T1199 and T1214, which are looking at the costs of installing this infrastructure, but also the challenges we have on the South East Third Rail network about putting full electrification in place, meeting the safety objections that are required there, where we're going to have to run with a third rail network in a low carbon environment and just need to make sure that's okay. Core to all of this, with the recommendations made by the task force, for T1197 in the middle of that, and then 1198 and 1201 on the right hand side. And these are all linked, trying to update the carbon footprint of the industry, make sure we know where the big impacts are, but also to identify all those sources. And finally, to identify who the guiding hands are, the agents, either individuals or organisations that are best placed to take action where targets are being set. On the right-hand side with those targets incentivisation, making sure that everyone's clear about the targets that are placed on the industry, how they may get allocated within the industry, and then also looking at what tools are available to help move the industry in the right direction. Obviously, the industry is still going to be looking at passenger satisfaction and performance against timetabling requirements, but we're going to have to make sure that carbon is going to be part of an integral part of the way that the railway is managed in future. And so the incentives, track access charges, cost of fuel, cost of carbon, other things that may already exist within the railway or that we can see are being used elsewhere within regulated industries, or perhaps in other rail operations elsewhere around the world, that may be brought in to act in both positive and disincentive terms to guide the industry towards a low carbon options in terms of traction, building, so on and so forth. But then making sure if we're doing that, that the implications are really well understood. Those two projects on the right-hand side are actually unusual for RSSB in that they're looking at technical stuff, but they're looking at some of the governance aspects. And we are working very, very closely with the Department for Transport, as they will be the ones who actually take responsibility for the final targets, for the final incentives that are put in place. So we won't be saying this is what you need to do. We'll be effectively giving them the best consolidated advice that we can provide so that they are as well informed as they possibly can be to make those sorts of challenging decisions that will affect the railway into the future. The work that we're doing is supporting a number of different additional elements. So DfT have produced a transport decarbonisation plan, which I think you're probably familiar with. It's being consulted at the moment. Network Rail is looking at areas for electrification. They've just produced their interim report and we're producing a final report next month to look at this, and the traction decarbonisation network strategy will finally produce a recommended map of electrification, hydrogen battery distribution across the country. We've consulted closely with people like the Committee on Climate Change and National Infrastructure Commission in producing our ideas. So the recommendations on net zero that led to these statutory limits were consulted through looking at what capabilities railway could deliver. In other areas such as project planning for the next half a dozen years or so, the rail technical strategy, and also more widely what the whole industry strategic plan might look like, and the sustainability contributions Network Rail is doing a piece of work for DfT, and the findings from this are being built into that as well. So this work is not sitting in isolation, it is feeding very clearly into a fairly wide range of different ideas and plans being developed for and on behalf of the industry at the moment. I mentioned about the transport decarbonisation plan. One thing we have to bear in mind, the task force mentioned this, the TDP mentioned this as well, is one of the challenges is to remove non-essential journeys. The railway is ideally positioned, although we're struggling at the moment as a result of COVID-19 and the slow return of passengers to the railway. In terms of being a low carbon form of transport, railway does stand out in key areas of high density, high intensity use, both for passengers and for rail. We should be looking to maximise the advantages, the natural advantages railway has in these areas in terms of encouraging modal shift as we move to the possible new ways of working post-COVID-19 and we recover from that. But it's very clear that DfT has, the rail industry has a really strong role to play in supporting DfT's decarbonisation challenges through that modal shift, providing confidence is returning in a reasonable manner. And that's going to be one of the key targets for and challenges for the industry over the next year to 18 months or so. We've also continued to consult on the future work that might be required. And you can see with Decarb 2, we've been talking with industry, had workshops, consulted through the various bodies, had individual conversations to find out what more needs to be done. And this is where I was saying that the industry needs guidance on how to put together its ideas, that we need to have action plans in place. Those will be incumbent upon the individual operators, the individual organisations within the rail industry to put together their own planning. But they need to have a framework against which they can put together a coherent structure. So that particular project will be looking at how the industry as a whole can put in place decarbonisation action planning. Similarly with the rail supply chain, we know that a great deal of the carbon that we emit as a rail industry is actually not directly emitted by the rail industry, but within supply chains, manufacturers, contractors, so on and so forth. So in making decisions on decarbonisation, we want to make sure that we're not just transferring that into other areas. Low carbon freight solutions is something where we've identified that there are potential solutions for freight, but we need to actually address some of the potential problems in more detail. And finally, low carbon train design is about designing this out, about streamlining, about lightweighting, about making onboard systems more efficient and so on and so forth. So trying to understand it in more detail. And then finally, on the right-hand side, further ideas, which are still in really early development stages, but where we maybe look at power distribution systems, low carbon fuels, carbon pricing, so on and so forth, where there may be sort of more integrated challenges for the industry to look at. But basically what we're trying to do, and this is the final slide, is to look at where we've got knowledge and skills gaps in the industry, where we need to be able to work across components of the industry to ensure that thinking is joined up, that although we're looking at long-term issues, that we're identifying those areas which need immediate and medium-term attention, which the RSSB can support, and which the task force can make sure it's monitoring, continuing to monitor, and where we're also supporting those research streams. But ultimately, whether it's as a contractor, a consultant, an operator, or whatever, that we're providing opportunities to flag up where we need to deepen knowledge, understanding, and competence in the industry. At the moment, we're still very much in the planning phase, but when we start working in detail on these areas, we're going to have a lot of people who know carbon and know the railway, who are really competent, and that demand for those sorts of people is going to increase very rapidly. So we want to start opening the window on those opportunities as well. So if you do have an interest in this area, we'd be very happy to hear from you to explore how we might be able to work together on that in the future. And that's it for me. Thank you very much. I think the microphone's off, yes.
Right, there we are. Can you hear me now? Andrew, thank you very much for that presentation, and some very good food for thought there. My initial thought actually was that with modal shift very much necessary, we've got a short-term problem in that people are in their cars, backed in their cars and not on the railway, and I hope that's not going to derail, no pun intended, the transport decarbonisation strategy that we're all signed up to. Right, let's go on to our second presentation. Is Casper Briskens, who's a head of strategy and development for Rail Baltica. He spent 6 years in leadership positions at Rail Baltica, and before that he was an advisor to the Ministry of Transport and Communications of the Republic of Latvia. So Casper, thank you very much for joining us. We look forward to your presentation.
Thank you very much, Norman, and many thanks to the Intelligent Transport magazine for providing us with this wonderful opportunity to take a few moments of your time to introduce the mega project, the railway mega project in Northeast Europe, in the Baltic states, and also to describe in some detail our approach to sustainability. Allow me to share my screen and share a few slides with you. Right, I hope you can see the slides now. So yeah, well, Rail Baltica is what we call the project of the century for the three Baltic states, because of course, in terms of the sheer size, the volume, and also complexity of the project, there has been nothing of that kind in the past at least 100 years. So in many ways, because Rail Baltica is a greenfield railway mega project, of course, we have the possibility of also developing a sustainability strategy with a life cycle perspective in mind. And what is very important, even though the name is Rail Baltica, we certainly view Rail Baltica as something much more than a railway project, certainly more than just a railway construction project. Because of course, as a super connector across the three Baltic states, also connecting Finland, connecting Poland and the wider region, it is very much about multimodal connectivity, and of course making it as sustainable as possible by capitalizing on this very unique greenfield opportunity. So here are some of the key highlights of the project. So the line itself runs almost 900 kilometers and almost entirely greenfield. So it's a European gauge, as opposed to the existing railway system in the Baltic states, which is wide gauge, 15-20 millimeter. It runs from Tallinn, the capital of Estonia in the north, all the way to the Polish-Lithuanian border. And then on the other side of the Polish border, our friends in Poland are developing also their connection and upgrading and building new alignment between Białystok and the Lithuanian border. So that is what is known as the wider Rail Baltica corridor. And the joint venture, the Baltic joint venture that I am privileged to represent, is taking care of the developments inside of the three Baltic states. So coming from Tallinn through Pärnu, which is the number 3 city in Estonia, to the city of Riga, also connecting Riga International Airport, then continuing into Panevėžys and Kaunas on the main line in Lithuania, and continuing then to the Polish border with a spur line also between Kaunas and Vilnius to enable a connection between the three capitals. It's a mixed-use line, so it's a high-speed corridor for passenger traffic with speeds of up to 250, which is by any metric high speed here in the Baltic states, as clearly there is no connectivity at such level and such speeds. But also, of course, it will have a very important freight component, with speeds of up to 120 for freight trains, and very importantly, also advanced criteria and advanced parameters to enable high capacity freight shipment, also to encourage a lot of modal shift and modal integration. So we will have 25-ton axle loads, train lengths of 1050, even with future extensions to 1500, as clearly this is pushing some boundaries in a European context, but in the context of the wide gauge system, 1050 meter trains, freight trains, is nothing unusual. And then also, again, because we are a greenfield, we will be putting in place the so-called Swedish loading gauge, which is, both wider and higher dimensions for all the different infrastructures along the corridor. So again, to enable high capacity shipments. And as a rule, Rail Baltica will have intermodal facilities, or dry port facilities on the crossroads between the existing wide gauge network and the newly built European gauge. One of the facilities will be located in the port of Tallinn, the port of Muuga. That will serve as the critical interface with Finland, as Finnish import and export is one of the key sources of future freight for Rail Baltica. And then also terminals in Latvia and in Lithuania. Because we are, sorry, this jumped over, because we are a greenfield, of course, that allows us also to put in place a sustainability or a low impact or impact minimization strategy across the life cycle. And we are today in advanced design phase. As of next year, large scale construction works will also start in some of the point type objects, such as a few of the 7 large international stations that we will develop. But also, of course, increasingly and gradually on the mainline track sections. Again, this is a line which is a double track line, ERTMS equipped, fully electrified, and of course, almost entirely greenfield. So certainly we will be looking towards the farther future into carbon neutral operations, hopefully with a 100% renewable energy use. We will be looking out to minimize the noise and vibration impact. Of course, also waste minimization, environmental resources management. And in terms of the level of ambition, if you go from zero fossil energy, which would be a relatively modest level of ambition for a greenfield project like Rail Baltica, and if you go further, we of course want to push that boundary and strive as much as reasonably possible towards zero impact. And then in terms of the life cycle assessment and planning of our sustainability strategy, we differentiate, of course, between the delivery phase, the construction phase, which we're currently at, and the operational phase. And the construction phase is, of course, very much related to the environmental impact assessments underlying the route alignment, underlying the different point type objects. And then, of course, going forward, we are thinking in great detail as to how do we optimize from a sustainability point of view our construction sites, in order to make them as compact as possible, in order not to interfere with the different protected areas, including environmentally sensitive areas. That also involves considerations related to the access to those construction sites, the traffic organization, fencing, security, and other elements. At the same time, waste management and pollution, anything ranging from waste storage to wastewater, rainwater, hazardous material management, construction waste management, and again, also noise, vibration, and of course, dust and particle pollution. Those are critical considerations, especially during the construction phase, and especially taking into account that some of the elements of our infrastructure will be done in highly dense urban environments, including the international stations, and of course, the line segments connecting these important urban nodes. And then in terms of the work organization during the construction phase, the logistics is absolutely critical. That also has a very important impact on the sustainability of the delivery phase. Of course, storage, including material handling and storage, also working hours, health and safety, accident risk management and monitoring. And very importantly, again, because this is a greenfield, because this is something where the Baltic states are relying heavily on the know-how and technologies available across Europe and beyond. I mean, because the Baltic states have never had a project of this scale, certainly not the independent Baltic states, then clearly Rail Baltica is already today a very nice strategic cooperation between international companies, predominantly European, and the local companies. And by that, of course, there's also a lot of technology and know-how transfer in terms of construction technologies and methods, which then, of course, also feed into the wider resource management for the construction phase, including with considerations about soil reusage, or basically reverting the soil back to its previous condition, also to enable recultivation. That also involves working with sustainable materials, handling those materials in a sustainable fashion, standardizing as much as possible, and of course also aiming at energy and water usage efficiency. And then of course, upon the construction phase completion, it is very important, of course, to continue site evaluation and monitoring, during a few years of initial operations, just to enable that, again, the soil and the conditions, the environmental conditions are safeguarded also during the early operational phase. And then going into the operational phase, there's a slight delay on the slides, but generally one of the pictures that I'm featuring here is a Zaha Hadid rendering of one of our international stations, which is the Ülemiste station in Tallinn, which also, of course, not only would be an architectural beauty, but of course has very important sustainability considerations underlying that, ultimately one of the signature elements, signature stations along the entire Rail Baltica. But in operational phase, of course, this is not just about the traction energy. Again, this will be a 100% electrified line, but equally so, it is also about minimizing emissions, noise and vibrations, also electromagnetic field, the air emissions, particle emissions. And again, just like during the construction phase, critical considerations related to water management, chemicals management, vegetation control, and also soil pollution management, and of course waste management and biodiversity and nature impact preservation. And all of these are, of course, we are considering already now, because of course, as a greenfield, we have that ability, instead of working in a brownfield environment where we have to take care of maybe obsolescent infrastructure, obsolescent technologies, and that adds additional complexity into delivering a low impact infrastructure. In our case, of course, we can take that ambition one level higher. And then regarding modal shift, and let me see if I can synchronize these slides for you. Okay, slides come with a lag, but the picture that I'm showing now is on modal shift. Even though I am personally not a fan of the term modal shift, because unfortunately it carries this kind of underlying connotation which juxtaposes some elements of the wider multimodal mobility system against the others. Rail is clearly the usual beneficiary of that juxtaposition because it's the cleanest mode of transport. But in our view, and that's also the Rail Baltica philosophy, of course, we are delivering Rail Baltica into a multimodal mobility ecosystem. So it's just one element in the wider either multimodal logistics supply chain or a multimodal passenger journey, where rail is one element in the wider chain. But at the same time, in the Baltic states, well, currently there is no feasible rail connectivity on the north-south axis, that is across the Baltic states from north-south or south-north, neither for passengers nor for freight. So clearly the potential for modal shift is enormous. Just to give you a few benchmarks, there are more than 5,000 trucks daily crossing the border between Poland and Lithuania. So that gives you an estimate of the intensity of truck traffic taking place along the Baltic states. So you have Baltic import-export traveling on that route, you have Finnish import-export traveling on that route, in parallel to the short sea shipping routes, which are also traditional gateways or traditional routes for Baltic or Northeast European trade channels. And then, of course, you have many private cars, almost 9,000 cars daily, again, crossing the borders. You have many flights per day currently connecting the three Baltic states. Riga is the bigger hub, but also there are major airports in Tallinn and Vilnius. And of course, the connectivity between these three critical Baltic airports is regular and high frequency. So at least 5 flights per day on a relatively short distance. So these are certainly candidates for future modal shift, but modal shift that builds heavily on modal integration. Because since Rail Baltica will connect all of the different elements in the wider Baltic mobility system, including the airports, as I mentioned, including the seaports, dry ports, smaller terminals, also regional stations. So of course, it's absolutely critical to make sure that that backbone, that railway backbone, connects and fuses together all of these different other elements of the mobility system. And through that also encourages not just the modal shift per se, but a more sustainable distribution of different elements across the supply chain or the logistic chain. So when we talk about freight, clearly we are looking for mostly for general cargo. So that will be the bread and butter of the Rail Baltica line in terms of freight. So a lot of that is intermodal, either intermodal between the existing wide gauge system and the European gauge, or trucks, truck or road rail intermodal, including with options for piggyback traffic, unaccompanied or accompanied. We are studying these options, and also a lot of options for less than wagon load. So not every freight owner and not every logistics integrator has the capacity in the Baltic states to form a block train, even though we'll have a fair share of those. But very important to also take care of less than wagon load. So that is absolutely critical. To enable that is to have these terminals with dry port functionality. Some of those will be directly connected to maritime ports. Again, they will be located on the crossroads between the existing wide gauge and the European gauge. And that in itself should facilitate that for as much as possible, that the shoulder should be as long as possible, and the economies of scale of rail freight should be taken care of. At the same time, also promoting a strategic cooperation with the trucking industry. They're allies, they're not just competitors, because of course the last mile distribution, first and last mile distribution is absolutely critical also to enable that, to encourage that modal shift. Otherwise, rail is oftentimes not competitive, especially of course with the fact that there is not really yet a level playing field also in terms of legislation between road and rail. But at the end of the day, in the future intermodal supply chain, road and rail are allies, including with the autonomous vehicle integration. And of course, digitalization as the enabler for that multimodal connectivity for these multimodal supply chains, with things like real-time tracking, with freight condition monitoring, digital documentation, and digital integration. And digital integration, not just on the rail portion, but across the multimodal supply chain. So railways should be able to talk to the trucking industry, to the air industry, to the maritime industry, and that should work as one unified supply chain solution for the ultimate freight owner or the lead logistics provider. And the final slide on air to rail connectivity. Again, there's a lot of discussion about rail replacing air passengers. There's certainly a place for that, especially for short haul and ultra short haul flying. And clearly there's a potential of that in the Baltic states. But equally importantly, it is also to ensure that air and rail are fully and seamlessly integrated. And as a greenfield, we have that opportunity to put infrastructure in place to actually enable future seamless intermodal journey opportunities for the passenger, including with things like interline and code share single ticketing between the rail operators and airlines, single check-in for the entire journey. Also, we are working on integrated baggage solutions, especially with regard to our international rail stations. You should be able to drop your bag in any of the Rail Baltica international stations and then go to any of the airports along the Rail Baltica route and receive your bag in the final destination. As long as the business case is there, we will put the infrastructure in place to enable that. And equally so, this is my final remark on intermodal logistics side. Clearly, there are major opportunities for air freight integration, especially with the rapid development of e-commerce, also high value, added value logistics services, including reverse logistics, customs processing, also smaller industrial operations like assembly logistics, labeling, packaging, all of these nice and clean jobs that can be created on the backbone of this transport connectivity, multimodal connectivity, should deliver sustainable jobs in the future, and are also a critical component of the long-term Rail Baltica sustainability strategy. And equally so, they can also be extrapolated also to maritime rail integration. So many thanks for your attention. I'd be happy to take questions after the panel. Thank you.
Casper, thank you very much indeed. A very ambitious programme, and good to see that so much thought's been given not just to proper planning, but also to the environmental sustainability of what you're planning to take forward. And that leads me on to another ambitious programme, which we're going to hear about perhaps from Rod Paris, Head of Sustainability and Consent at Crossrail Limited, which is of course the new line across central London. Rod.
Thank you, Norman. Good morning, everyone. Right, I'm just going to get all these tech pieces out of the way first. And that should get the screen share up. Good. And one final click. Who knew that the most daunting part of a presentation might be clicking some things as opposed to giving the presentation itself? So I'm going to talk to you about Crossrail and carbon reduction this morning, but the first thing I'm going to do is not assume you all know exactly what Crossrail is and just do one slide of introduction, setting the context framework on which the rest of the presentation should sit nicely. So what is Crossrail? It's a new railway scheme, not a new tube line as some people think. It's a metro style stopping service running across London and the southeast. And it consists of two main parts, a surface section, which you can see here in blue, and that is located on primarily existing railway corridor, mostly the Great Western Main Line and the Great Eastern Main Line corridors. And then there is the bigger piece of work, which is the new central section shown here in red, which is 21 kilometres of new twin-bore tunnel, or 42 kilometres of tunnel in all, about just over 5.5 metre diameter. And a whole raft of new subsurface stations, all linking in with existing transport nodes, which you can see here. Primarily, it's a publicly funded project. The two main sponsors being the UK government through the Department for Transport and the Mayor via Transport for London. When it opens as the Elizabeth line, it'll add 10% new rail capacity at a stroke to London and the southeast. And in terms of its delivery, the central section is being delivered by Cross London Rail Links and our contractors, and the surface sections is being delivered by our partner Network Rail and its contractors. Last piece of useful context. The powers and the deemed planning permission that enable us to construct Crossrail come from an Act of Parliament. It's known as a hybrid bill scheme. Some of you on this may be familiar with things like Transport and Works Act orders or Development Control orders, but our powers come from an Act of Parliament. So like High Speed 1 before us, and indeed High Speed 2 now. The reason I emphasise that slightly is because the Crossrail Act 2008, that's when it got royal assent, was the same year, of course, as the UK got its Climate Change Act. And it's worth reflecting that in the years that have passed, now there are a lot more tools, drivers, policies and experience that have helped facilitate carbon reduction. But back when we were kicking off, moving into a delivery organisation, a lot of that didn't exist or was very much in its early stages of evolution. So there was a lot of learning to go through. We put together a carbon footprint policy in 2009. And we had a certified EMS by 2010, within which we put energy and carbon footprint reduction targets and objectives, and some of those will come out as this presentation progresses. So also in 2010, that's when we really put together our main baseline carbon footprint. Crossrail has a design life of 120 years. So it came as no surprise that almost 80% of the carbon footprint for Crossrail comes from operation. And the majority of that is through locomotives and operating a passenger service, and only a very small percentage of that is the actual energy consumption of the infrastructure in the stations, the shafts and the portals. Crossrail is actually powered by the grid, so it's very much dependent on the grid mix as to how that carbon footprint comes out. And in construction terms, you'll see that in round numbers, about 20% is construction carbon or capital carbon as it's considered. And the final thing to note is that when we did that carbon footprint, we realised a lot of old diesel passenger services. So in comparison to a do nothing scenario or a do minimum scenario, there was going to be a carbon saving by the operation of Crossrail. And that meant that in round numbers, between 8 and 13 years, we could get a carbon payback on the construction, which is a very fortunate position to be in. And that range just depends on things like assumptions about what the energy efficiency might be of the various trains and what the grid mix carbon will actually be in the future. So the sorts of things that we could impact upon are the energy during construction, the embodied carbon, the first generation of rolling stock, and the first generation of the mechanical and electrical plant that went into the system itself, the infrastructure itself. And so taking you to the beginning of that, when we looked at design, we decided to set holistic design targets in terms of sustainability rather than specific. So we didn't have specific energy targets in the design, but for our stations, our central section stations, we adopted BREEAM, Building Research Establishment Environmental Assessment methodology, a leading methodology in the world today and at that time. And we set a target for all our central stations of achieving a very good certification, both in design and assent, and a stretch target of excellent. And for the civil infrastructure, the tunnels, the portals and the shafts, we adopted CEQUAL, the Civil Engineering Environmental Quality Award Scheme, and we targeted excellent for all of those. And speaking to you today, where we're at, all of the civil infrastructure has actually come in at CEQUAL excellent. And on the stations, we're still going through that, but 3 of the stations have come through certification. 2 of them have achieved very good. 1 of them has achieved excellent. The others, the remainder, are on target for very good, and 2 of them could possibly achieve excellent too, which would be a wonderful outcome. And the adoption of those schemes meant that it helped to drive sustainability design. Now, having subsurface stations, there wasn't a huge amount we could do in terms of getting natural daylight down into the system. But at one location in particular, Paddington, we were able to do so. Now, this is a CGI, but nonetheless, we have actually been able to do this. This is, as you come down into Paddington Station, there is a big canopy structure over the top, and the natural light is able to come down. So that was a nice outcome that we were able to achieve in the design process. I'd also point out, going back to that whole date issue, when we originally specified the railway and set up the contracts, we were going to have what you might call traditional luminaires, a traditional lighting system. LED lighting wasn't entirely proven at that stage, but was coming up hard on the outside, as you might say in racing terms. And when that actually developed and could be accepted, we then adopted that into the system quite early on. We've got LED in all the tunnels now and in all the infrastructure, including back as well as front of house. And that in itself gave us about a 63% energy saving on what we would have had if we'd stuck with that initial specification that we were going to run with. Lifts and escalators was another big one that we could affect in terms of specification. Again, go back to that time, we were looking around to see what the baseline was, what good was, and we could see what the London Underground standards were for lifts and escalators. And we specified lifts and escalators that would be about 23% more energy efficient, and again, used LED lighting and these sorts of elements. And whilst we're still in the testing and commissioning phase, improving some of these things, it is coming out at about 23%, which is really good. So that's the specification, that's the tech, if you like, inside the stations and the infrastructure. I've mentioned embodied carbon. Now, Crossrail, for all its complexity, and it is a hugely complex scheme, when you look at the materials, by far the greatest volume is in concrete and rebar. If you think about it, if you're going to build that amount of tunnel and have that amount of subsurface station, there's a huge amount of that that goes into the construction. So on the concrete, one of the places we could focus to bring carbon down was on cement replacement. And we had a minimum standard in all the cement mixes of a 50% cement replacement, but we encouraged all of the contractors to do better than that where they could. And indeed many did. And the top performer was actually Paddington Station again, where they actually managed a 72% cement replacement with associated carbon reductions that come with that. Couldn't always achieve that sort of level because there's sometimes around the concrete performance, there's requirements you have to meet, and so you have to affect how much replacement you can put in. And sometimes the curing times, it can affect that, and depending on how quickly you need it to cure, you can't always go as high with replacement as you'd hope. But those were some of the things we did, and there was quite a big win we had on the embodied carbon side. Construction carbon, the activity of construction. Now, this was an interesting one. When we were setting up the contracts, we went out to the market and we asked, what experience people had, projects had, of setting carbon budgets or energy targets to drive down construction carbon. And really nothing came back at all. There was really nothing that came in. So or certainly nothing you could apply to a project that was the size and scale of a railway project like Crossrail. So we took the approach that once we procured all of our contracts, we gathered all the contractors together and we asked them what they thought would be a fair target to try and achieve. And they came back variously with numbers of between 4 and 8% construction target. So we adopted 8. And what we also did was, in order to be able to measure that, working again with the contractors, we developed a carbon model, a construction carbon model that we could apply to each site. And each site then had a reference or baseline model that was set up for it. And then when they adopted certain energy efficient technologies like LED lighting or hybrid equipment and plant, so that then achieved certain savings. And that way we could track and measure what the performance was in terms of meeting that 8% carbon target. Now, because we did this post-contract award, these weren't targets that were in the contract, we needed a way to facilitate and encourage meeting that target. So I'm going to make a very small diversion, but it is a relevant diversion as to how we actually encouraged that during the delivery of the project. And that was with something we called Supplier Performance Assessment. Now, the Crossrail contracts had a lot of requirements in them, and we wanted to know how the contractors were going to perform against those. So the various areas we were interested here are shown on the left. Got environment target 0 was health and safety, commercial, and the other ones there. And so on a 6-month basis, we would effectively go out and sort of audit the contracts, and we would be able to see were they compliant with the contract, non-compliant, or were they even going further, what we call value added. And in some cases, they might even be leading edge in the industry, what we called world-class performance. And what that enabled us to do was get a graph like this. And here you see over 5 of those assurance assessments, all of the contracts in all of the areas and how they performed. And you can see that on average, we started off at a broadly compliant level that moved up into that value added, and then it slowed. And that's not surprising when you consider what value added means and how difficult it would be to get everything up to world class. And you could break that out into the various areas. So this is the environmental performance. You can see the averages in the golden triangles there over the 4 periods. But the great part of this was that each contract could be identified individually and its performance tracked on the graph. And each of those round circles there, the blue circles, is a contractor. Now, because we put this process in place, again, after the award of the contract, the buy-in that we had to sort of sell with the contractors was that we would make it anonymous. So they each knew what their number was, but they didn't know what their peers' number was. So that was the deal that got them to buy into the process. What was fascinating was that the very first time we did this, we had our contractors forum and all the delivery directors from the contractors turned up. And no sooner had we put this chart up than they all started asking each other what number they were. So in no time, anonymity was out the window. They all knew where they sat. And what then developed was this wonderful, healthy competitiveness, because none of them wanted to be seen to be lesser performing than their peers. And that's what really helped to drive that performance that I was mentioning earlier. And why do I pick this out? Because under environment, we had energy performance as well. So you can break out the energy performance, and you can see here that when we did the first assessment, we were actually not performing that well. And then very quickly, it came up out of non-compliance into compliance and then moved on to value added. And it's worth bringing in a second element that we came in to facilitate the driving of meeting that 8%, which was we had, at that time, we had Crossrail delivery directors, and there was an incentive scheme for them. And there were various things in that incentive scheme to drive a bonus, and one of those was achievement of the 8% target. And why do I highlight all of that? Because whilst we set a target of 8%, we actually have achieved in 2008 when we closed 2018 when we closed that scheme down 18.6%. So that was a really wonderful outcome in terms of driving down that construction energy. On the operation, we sort of set two main targets here. One was train weight. We set a target of 350 tonnes for a 10-car consist. Around that time, industry was going for something like 400 tonnes. So we directed for under that. And an energy efficiency of 24 kilowatt hours per train. Bombardier, based up in Derbyshire, they were the successful contractor for this. They brought some of their aerospace engineering experience to bear, and they smashed that weight target, coming in at 319 tonnes. Our new trains are 319 tonnes. And when we were doing testing and commissioning about a year and a half ago, we were coming in at about 14 kilowatt hours per train. And on a Crossrail pattern, that means that we were going from about a 55 grams of CO2 per passenger kilometre to 32, which was a wonderful outcome. And you can see listed here are other things that were also brought in to make the trains as energy efficient as possible. Things like regenerative braking are standard, and the driver advisory systems to enhance energy efficient driving. And my final slide is just to say, so what was the outcome of all of that? Well, we're still finishing the delivery. We're still wrapping up a final carbon footprint, but I mentioned that 8 to 13 year payback period. It looks like we might be able to claim that we've shaved a year and maybe even 2 years off of that, maybe between 8 and 11 years, which if we've done that, we'll be very happy. Now, I've given you a real whistle-stop tour through our carbon reduction measures, but if anything of that was of interest to you and you'd like a lot more detail on it, and believe me, there is, we've developed this Crossrail Learning Legacy website, and you can go into here and you can find case studies, best practice examples and various papers that will give you a lot more information on all the items that I presented to you this morning. That's it from me, except to thank you very much for your time and attention this morning. And in time-honoured Zoom fashion, I now need to stop my share and go on mute. Thank you very much.
Rob, thank you very much. And that's hugely encouraging. And I'm particularly interested in the competitive environment performance aspect, which has clearly been very successful. And I might say I'm old enough to have been not just on the Jubilee line when it first opened, but the Victoria line when it first opened in 1968 or thereabouts as a young lad. So I'm very much looking forward to being on, I suppose, what we now call the Elizabeth line when that opens as well. Can I just remind those who are watching that you're invited to submit your questions into the questions box, and they'll be answered in the speaker Q&A, which will begin after our last speaker, which leads me on to introduce Mark Starkey, who is interested and leads on safety, quality and environment for MTR Corporation and responsible for leading the development and delivery of the UK rail industry's first truly joint safety and environment strategy, about which we're going to doubtless hear more now. Mark.
Morning, everyone. I will again attempt to share my screen, so bear with me a second. Let's try this, which appears not to have worked. I guess nobody can see my screen, can they, currently?
Mark, it has worked, so you can carry on.
Fantastic. I'm surprised even myself there. Thanks, everybody. Good morning. Thanks to our previous speakers. Really, really interesting. So hopefully I can maintain that level of interest before we wrap the session up. So good morning. My name is Mark Starkey. I'm the Safety, Quality and Environment Director for MTR Elizabeth Line. And I want to give you an operator's perspective. We had some really good presentations around the more like a long-term look at reducing carbon emissions, and I'm going to talk to you about what we're doing on a more day-to-day basis, on a more practical basis, I think, just to provide some context. So what am I going to talk to you about today? Well, I'm going to talk to you about the MTR Elizabeth Line, who we are, what we are and what we're doing. Give you that perspective on an operator's role in a carbon smart railway, touching on things such as rolling stock, how we operate trains, how we operate stations, our processes and our people, and then wrap it up a little bit at the end with a very quick summary. So who are MTR Elizabeth Line? Well, we're the train operator for, as Rob explained, Crossrail. Now going to be called the Elizabeth Line, thanks to Mr. Johnson a couple of years ago. We are owned by a Hong Kong-based corporation, MTR Corporation. Lots of experience in running metro-style operations, subsurface operations over in Hong Kong, in mainland China, Sweden, Australia. So we've got a very good background and a lot of support that we can call upon. And we'll be the train operator for the Elizabeth Line. So we'll be running the trains from east to west through central London, and we'll be operating a number of the stations as well, alongside our colleagues in Greater Anglia, Great Western Railway, and of course London Underground. So Rob's already touched on this, so I don't need to spend too much time. We can claw some time back on the description of what the Elizabeth Line is. This is what it looked like on the tube map inside our trains when it's all finished. But currently, we look forward to receiving the £15 billion railway that we've all seen on television running through central London. But we currently operate the trains and the stations on both the east and the west on the legacy network, the Network Rail infrastructure. So from Shenfield in the east into Liverpool Street, we also run Abbey Wood in Kent, and obviously we run trains from Paddington to Reading and to Heathrow on the west. So something along the lines of 11 stations on the west, 12 stations on the east, and obviously the train services connecting those separate legs. We look forward to connecting the middle part as well in the near future. So we've talked a lot about carbon targets. We talked about the 2050 target in Andrew's presentation earlier. Is zero carbon really realistic? Well, I think that's probably a bit of a wider debate to be had, certainly above my pay grade. But I can give you the MTR perspective or an operator's perspective. We've got a short-term contract. Our contract is 8 years, starting in 2015, with an option for 2 years. So only really a 10-year contract. That makes long-term investment decisions quite difficult for an operator, for a concessionee, if you like, or for a franchisee, for the DFT franchises. Whilst we've had no involvement in the design specification, Rob talked about setting the carbon policy back in 2010, and all the design specifications around that. We've had no involvement in that. However, we're pleased, obviously, to be involved and receive these energy efficient trains and stations that Rob's worked so hard to deliver to us, and we hope we can run them in an equally efficient way. Our view really is that we are not looking to eliminate carbon emissions. We are looking to manage and reduce as much as possible in the time that we have in being the operator for the Elizabeth Line. So what does that mean in terms of the various items that we have to look after? So in terms of rolling stock, electrical current for traction, so EC for T, accounts for 90% of our total energy usage. So 90% of the energy that we use to operate the Elizabeth Line is used by trains. Yeah, Rob's already described the class 3, 4, 5 trains that we are getting, some of which are in operation. There will be 9-car units with a 1,500 person capacity. We've got both 7-car units and 9-car units running around currently. They'll have regen braking, they'll have on-train metering, so we can provide that consumption information to drivers, so drivers can drive more efficiently, and we can work out the most efficient way for a driver to drive. They have automatic temper control, auto door closing, etc., to help maintain that environment within the saloons and keeping the saloons comfortable for passengers, which is all fantastic. And you can see some of the pictures there, the 345s lined up outside Old Oak Common. In reality, however, due to delays with the programme and delays of the project, our railway looks a little bit like this. We have the shiny 345s, the fantastic energy efficient trains on the left hand side, but we're also running 315s, the old workhorses that have been delivering people into London from Essex for a long time. We've only recently just got rid of the 360s as well from Heathrow Airport. So that's been a challenge for us. We know that 345s at the moment, whilst they have these fantastic energy efficient technologies such as regen braking, which is ideal on a metro style operation such as ours. The regen braking isn't operable currently. The train metering isn't operable currently. We can't feed back information to drivers currently. So unfortunately, until we get that fixed, we're a little bit stuck in terms of the information we can provide to drivers and the decision making we can take to reduce energy consumption with regards to rolling stock and train operations. However, what we can do to reduce traction energy is around how we operate the trains, our train operations. It's really important for us, again, just remember there that 90% of our energy usage is relating to train operations. It's important for us to have efficient diagramming, minimizing empty coaching stock. So moving fresh air around is not particularly environmentally friendly, not particularly energy efficient for a train operator, reducing those non-essential journeys. And again, that's difficult for us because of the delays in the project. We've got a lot of drivers, we've recruited a lot of drivers that are struggling to maintain their competence because we can't give them enough driving time. So therefore, we're having to use empty coaching stock paths. We're having to put train driver training trains out there, which again, unfortunately, doesn't lead us to be as energy efficient as we would like. However, where we are doing exceptionally well, and I think what's key to providing a carbon smart railway and encouraging people out of their cars onto the trains, is delivering a really high performing punctual railway. And as a train operator, that is what we strive to do. And that ultimately is what's going to make us a successful operator and is going to have massive benefits for customers, for the safety of the railway, and also for the carbon emissions and the overall energy efficiency and environmental impact of our railway. Things such as preventing and recovering in disruption. That's really, really important for us. So what we might not automatically think about, things like making sure drivers and station staff are appropriately trained and competent to avoid operational incidents, making sure that everybody understands their safety responsibilities so we can again avoid safety incidents which invariably lead to the railway being disrupted, making sure that we work closely with our infrastructure partners, Network Rail and RFLI, to make sure that assets are maintained correctly. If we do all of those things, we avoid the railway stopping, we avoid disruption, and we can deliver a punctual and high performing service which people want to use as a choice, as opposed to getting in their cars and taking their cars to wherever they want to go. Very difficult at the moment, obviously in these COVID times, but because we're actually one of the highest performing railways in the country, we're seeing patronage up to currently 55% of our pre-COVID level. So I think we're doing pretty well there, and that's testament to the fact that again we are a high performing railway. So that's trains and train operations. Rob again has already highlighted all of the environmental and energy advantages of the fantastic stations. If anybody has had an opportunity to go to any of the Crossrail stations, you'll see they are cathedrals. They are absolutely magnificent, fantastic design, energy efficiency baked into the design and the construction, and we're a real asset to the project. However, we haven't got those yet. Rob's going to deliver them to us shortly, and we look forward to working on them. Our stations look a lot more traditional. We've got Brentwood there on the left-hand side, and some familiar sites for those of you that travel in using ordinary stations, ticket halls, gate lines, and some footbridges there. Yeah, we have to manage legacy infrastructure, which means that we have to manage environmental impacts and energy efficiency on stations that were not necessarily designed with environmental impacts and energy efficiency in mind. So we have these legacy stations on both the east and the west of our route. We have to work very, very hard to try and make those as efficient as possible. We've spent a lot of time, a lot of money retrofitting stations with LED lighting, which is now obviously proven to be of a massive benefit in terms of carbon reduction. We've retrofitted automatic meter readers, really important, as with the trains. You can't manage what you can't measure and monitor, so that's proved really, really effective for us. And we've made sure that when we refurbish stations, we have energy efficient specifications such as water saving features, LEDs, PIRs, effective glazing, etc., and solar panels for things like help points and smaller appliances like that. We've also switched to 100% renewable electricity and gas supplies. Really simple thing, but that does help us, and it's the right thing for us to do. And as the price actually becomes much more favourable in terms of renewable electricity and gas supplies, that seems a sensible thing that we should probably be doing more of as an industry. But just kind of take you back to energy and environment management 101. How do we keep energy and environmental management at the forefront of our board's mind, given the fact that, again, if we're talking about non-traction energy, only accounts for 10% of our total energy usage? Well, we do it via the traditional ways of making sure that we have our environmental management systems in place, we have our energy management systems in place, and also that we use the SECR greenhouse gas reporting. So it just keeps the environmental and energy challenges at the forefront of our board's mind. So we measure, we monitor, when we take corrective actions, and when we set objectives around energy and environmental issues within our organisation. So nearly at the final slide now. I come from an environmental management background, and if I've learned anything over the last last 20 years of work, it's that we're not going to achieve anything without taking our people with us. We've heard from Caspers around the fantastic infrastructure projects in the Baltic. Rob's obviously talked about how great Crossrail is going to be, and all the good work they're doing. Andrew talked about the research that's going on across the industry. From my point of view, how do we really bring those to life, and what does that mean to the man on the street or the frontline staff? We can make that accessible to people, but they need to understand it. They need to feel they're involved in it. We talk about the train metering, we talk about the driver machine interface for the drivers. That isn't there yet. So how do we make energy efficiency and environmental management real for the guys on the shop floor? The guys that are our eyes and ears, they can spot when things are going wrong. They can spot lights that are being left on. They can spot leaks, etc., etc. It's important. It's so important for us to make sure that we engage them. We give them apps so that they can report issues when they see them. We hold annual sustainability weeks, fun activities, really to drive home the environmental and energy efficiency message, and we appoint environmental champions as well to really gain buy-in and momentum on the shop floor, and that's really important for us. I don't think we can lose sight of that it's not just around the embedded carbon in steel rails or concrete. It's actually the guys at the sharp end that can help us make a difference as well, even though we're again only talking about 10% of our total energy consumption being related to non-traction energy. So in summary, reducing energy consumption significantly is hard for us, given the fact that we've got legacy infrastructure, so stations, and legacy rolling stock out there. When the Crossrail project comes online and we have the 345s running from east to west and all the benefits that will bring, we'll see a huge benefit in terms of our energy consumption and energy efficiency. However, we are pretty proud of what we've achieved so far in terms of managing our environmental impacts and our energy consumption. With regards to train operations, I've talked about the retrofitting at stations and making stations as efficient as possible. Talked about some of the processes that we used and how we involve our people, which is really important for us. So I'll just leave you on with a final thought, really. As a train operator, and I mentioned it before, it is vitally important that we deliver what our customers want. Our customers want a high-performing, punctual, safe railway that recovers from disruption. Disruption is going to happen. It recovers from disruption as quickly as possible, providing the right information to customers to enable them to make decisions about their journey. And one of those decisions should be, I don't want to use my car, I want to get on the train. And that's going to give us a huge environmental benefit. So I will attempt now to close my slides without cutting everybody off from this call. Thanks for listening. I'll hand back to Norman.
Mark, thank you very much indeed. And we've got a few questions which have come in now, which I'll try to run through. I'd be grateful if people are able to answer them as quickly as you possibly can, so we can get as many in as possible. The first one I've got in front of me comes from Stefan Hug from HBI Harter Consulting Engineers, particularly for Andrew. My company, based in Switzerland, has been looking to reduce the energy consumption through smart train speed profiles for a given route. Is that something that is feasible for the UK, or does it not yet have the necessary trackside equipment on or rolling stock? Andrew.
It's something we're looking at. I didn't mention it, but we've been doing some first-of-a-kind studies which have been looking at modelling particular rail journeys. And one of the things we're interested in doing is looking at how we do route journey optimization, both in its own right and across the system as well. So that's certainly something we can look at.
Okay, that's great, and thank you for your brevity there. One for Rob. Since construction began, what has been the most difficult sustainability challenge to overcome? Have you had to adapt along the way?
Sticking with the carbon, it was actually developing a baseline to start with, because when you set a target, what is that target against? So the biggest challenge we had was, in fact, is forming those baseline or reference sites, as I called them. So getting the model together, that took some time, and we did that working with the contractors, a lot of contractor input. So all congratulations to them. And then just getting these sort of modules that enabled us to measure what the benefit of it actually was. So if you take a step, LED lighting, how much credit does that really give you? So that was the big challenge. Now we've done it, I think others can probably do better. If you were to say what's the thing for the future, well, we set a target of 8%. We've achieved 18%. Well, that suggests maybe we should have been grander in our target setting in the first place. Maybe 20% or more is what the industry should be aiming for now.
Did you look at other schemes across the world when you were setting your baselines?
When we were setting that construction target, yes, and there was really nothing coming back, and that was the challenge, which is why we asked our contractors what they thought was good. Our idea was that if we set ourselves as a baseline project, others could then look at what we've done and build on that, and that was the approach we took.
Okay, that leads on to Casper's quite nicely, perhaps. A question here from, well, nobody's given their name, but it doesn't matter very much. Casper's, are you learning from other big greenfield construction projects around the world about the sustainable efforts and how they can be applied to Rail Baltica?
Absolutely. I was just hearing what Rob was saying. I mean, the Crossrail learning legacy is a marvel. It's a wonderful resource that greenfields like ourselves are tapping into. Also, High Speed 2, of course, has very interesting information available, and of course, we have great contacts there. Brenner Base, some of the Swiss tunneling exercises, all those major mega projects, the Fehmarn Belt, the Øresund connection in itself is a very interesting sustainability case where you had a lot of environmental resistance to the Øresund bridge connection, but ultimately turned out to actually contribute to more biodiversity in that region alongside all of the socioeconomic benefits. So indeed, I mean, if anything we can do, the least that we can do is try and benchmark from the best and from some of the more successful existing, that used to be greenfield projects.
Great. Okay, one from Way Evelyn for Mark. What initiatives are being implemented to achieve 100% renewable electricity for the stations? What's the payback period?
Well, we've procured all of our energy for stations. So our non-traction energy now is from 100% renewable suppliers. So we've kind of taken the shortcut there, but that doesn't negate the fact that actually, you know, again, it's not around, you know, where the energy comes from. It's reducing that energy in the first place. So you know, moving to renewable energy is one step, but actually reducing our consumption on a station, you know, using technology such as the LED retrofitment, PIRs, etc., is really important for us.
And presumably, you talked about Paddington. You talked about passive energy as well.
Yeah, well, thankfully that falls into Rob's domain. We're looking forward to those stations. And when you have a station construction project, you can build those in. Retrofitting is much harder for us, but yeah, well, we look at those options where we're retrofitting stations and building new ticket halls, for example. But unfortunately, we don't have the opportunity to do anything at such a grand scale as Paddington or Canary Wharf.
Well, Tottenham Road looks good, I can tell you that anyway, having been down there already. Now, we're running a poll alongside the session. So here's a question for everybody here. Do you think the rail industry is doing enough to reduce its environmental impact? The majority of responses so far, I don't know how many we've had, is no, which seems a bit harsh, but do you think that's fair? Anyone want to take that question?
I'll come back to the point, Norman. We need to make sure our railways are high performing. That is so important for me. Constant disruption for passengers, not giving passengers the information they need during disruption. Connectivity with other modes is so important, and that's why from an operator we've got such a big responsibility. Not just from a staff point of view, but from an environmental point of view, there's such a big responsibility to make sure our railways are as efficient and as punctual and as safe as possible. That's how we will get people away from other modes of transport onto our sustainable modes of transport.
Okay.
I can perhaps add something there as well. Rail traditionally has always been seen as a low carbon mode of transport and has not really had to do very much to demonstrate it is the low carbon mode. With the challenge to decarbonise to effectively net zero tailpipe emissions by 2050, we've got to show that we're actually doing that as opposed to just being able to make the claim. This is going to be increasingly the case as options for decarbonisation of road transport in particular come into place. So one of the things we need to do is demonstrate not only that we can get to net zero by 2050, but also demonstrate that the pathway we're choosing is going to still be advantageous when compared with road transport. Can we demonstrate at the moment? The answer is no. So we're probably not doing enough. Could we demonstrate it? Yes. Are we going to be choosing the most effective manner? Don't know. We know that we can decarbonise because effectively if you electrify the whole railway, you've got a zero carbon railway if your electricity is coming from the right sources. We know that's not going to happen. So we've got to find the way to decarbonise, which is actually cost effective and makes railway an attractive option for both passengers and freight.
And do you think hydrogen and battery technology will deliver that?
In a balanced environment, the views that are coming through from the technical analysis are suggesting that that's possible. We'd still have to do a substantial amount of additional electrification, but in areas where electrification is not possible, technical solutions are available with hydrogen and battery. Okay.
I mean, Mark, you've been looking at stations, but I mean, some of your legacy stations, like other ones in the country, no doubt, will have perhaps unenvironmental aspects to them. And I'm thinking perhaps when I go past stations, which are in the middle of the night, there's lights on everywhere, and every single light is on full. There's no attempt to dim them or anything even. And also trains sitting in sidings with lights on all day. I don't know whether we can do anything about that, not to mention diesel trains sitting in stations pumping out fumes when they're not moving. So there's quite a lot to be done on the existing network, it seems to me.
Absolutely right. We're fortunate that our trains, we have diesel trains, they're all fully electric. But I've worked for MTR now for 6 years, and previously I was at South West Trains for 7 years, and we were talking about the same thing when I first joined the railway, about trains being left in stabling sidings with lights on and idling away there. We talk about lights being left on stations, and at SWT we found a number of solutions for that. Those solutions are out there. I think, yeah, it's not rocket science. We just need a considered push on that. And I come back to and you'll know, Norman, yourself. I come back to the way the concession models and the franchise models work. We need to incentivize operators to push it further up their agenda. And yeah, in simple stuff like that, I think will help us.
Well, I'm wondering what opportunity there is now. We've got a new 18-month period from the government here in the UK to keep funding going in the short term, at least whether or not, as part of the Williams review and the forward look for railways, whether we can incentivise environmental performance rather more than we have done to date from the rail operators, even if they are concessions. I don't know whether anyone's got a particular view on that.
The concession that we have and the contractual arrangement that we have with TfL are far more strenuous than a franchise,
Right.
and I think that's a really good thing, coming from a franchise environment. It really focuses the mind, and I think if the DfT can kind of move that way in the future, for me, I think that's a good thing.
Great. Well, Casper, can I ask you perhaps? You've got this fantastic project which you've outlined for us today going forward, but what about your legacy railways? Is attention being paid to those?
Absolutely. Well, in some ways, Rail Baltica will be isolated, so we will not have same grade crossings. Of course, in the main international stations and the freight terminals, you will have the wide gauge and the European gauge side by side. But generally, of course, part of that intermodal offer, both for the passenger and for the freight, is integration between Rail Baltica and the existing networks. For example, some of the existing commuter networks in the bigger cities in the Baltic states are wide gauge. So of course, achieving that integration and ensuring that feed and defeed from the high-speed Rail Baltica is absolutely critical. And for freight, 1/3 of our estimated freight volume in the initial years should come from transshipment between the existing wide gauge system and Rail Baltica. So stuff coming from Russia, Central Asia, all the way to China, from China, being transloaded onto Rail Baltica and then continuing westbound. So clearly that intermodality between these two systems, even if technologically they will be almost fully isolated, is very important. And then also achieving that kind of digital integration and the technical standards as far as possible is very important, because we want to have two high-performing systems, not just the old legacy system and then the shiny new Rail Baltica. Both have to work in concert.
Indeed. Now we've got time, I think, for one more question before we run out. So it's one from Sergio Machada, I hope I've pronounced that correctly, directed at Mark. In the absence of a driver advisor system, what specific training has there been for drivers, and how is rolling stock energy savings being measured?
So yeah, for us it's very difficult, because we can't really adequately measure the energy consumption of our trains at the moment. The 315s don't have meters on them. 345s have meters, but that aren't being used currently because they're not operational. So we're taking our consumption from Network Rail's EC4T bills, as we did 15 years ago, which is probably not the position we want to be in. However, it can be done. We're not doing it currently because actually we're waiting for the 345 technology to be implemented fully. But again, a previous role in Southwest Trains, we were able to work out some driver golden runs, if you like, and provide training for drivers on the simulators. And I think Rob talked about that healthy competition. There's no one more competitive than the train driver. And if you set them the challenge for driving as efficiently as possible on a simulator, which can be done, it soon gets the message across. And that's something that we are trying to implement at MTR as well.
Great. Well, that's it. I think I want to say thank you very much to our panel, Mark, Rob, Caspers and Andrew, for some very interesting material. I hope people are encouraged by the care that's been given to environmental and sustainability issues on our railways, and the progress that's been made towards a cleaner zero carbon railway, and indeed, if I may say so, towards appropriate modal shift. So thank you very much indeed to our panel, and thank you very much to the audience. And now we're about to be cut off, I think. Bye-bye.